Good afternoon, everyone. Welcome back. Today we have interesting session using Apple Sysdiagnose for forensics and integrity check. We have three speakers from the European Commissions. We have start with David Durvaux, and then we have Mr. Aaron Kaplan and Emilien Jamtel. So three of them, they will present for 30 minutes. Thank you. The floor is yours.
Hello, thanks for the introduction. Does it work? No? Okay. So thanks for the introduction. As it was indeed explained, we were really here to present a bit of research we have done with specific use case we have in mind. So the issue we have usually is that when we do forensic on iPhone, mobile device, or computer in general, that contains user data, we have the issue and the obligation to limit the acquisition to the bare minimum, and especially try to avoid as much as possible capturing user data. Plus, we also don't want to jailbreak the device, which is a bit the issue with certain solutions as well if you want to have a look at what is running at the operating system level. So that's basically how we started. That was the question we start considering. How can we do that? And then we come to this. So Sysdiagnose is actually a feature that exists on all Apple device, being a watch, being Apple TV, being a Mac, and being an iPhone or an iPad as well. So the aim of Sysdiagnose is to profile the device, mostly for debugging purposes. So it targets developers that can have a bit of information on what's happening on the device, as well as Apple themselves. Typically, you can see information about the battery usage, when the device was loaded, hardware issue, and so on and so forth. But then we took this and we looked from another angle. From a forensic perspective, does it make sense? So, just to introduce a bit ourselves, Emilien, who is the head of the DevSecOps at CERT-EU, Aaron Kaplan, working in my team at the European Commission, and myself, I'm in charge of one of the sectors in the European Commission, the institutional S1. So, the problem statement, as we explained. We actually started before Pegasus, another nice malware that were found on iOS. With the question I already explained, how can we check the integrity of a device without jailbreaking it, and ideally without having to capture user data as well. Then come this report from Amnesty, which was quite interesting because it proved that somehow what we were willing to do was making sense. And then we look a bit at what Pegasus work and what was described in the report. And we also look at the technique that were proposed by Amnesty, and especially the MVT, so the Mobile Verification Toolkit, which was released by Amnesty as an open source tool as well. But then, why did we do that? As I said, we are forbidden by corporate policy, or at least wish to get user data as much as we could. We know Sysdiagnose is quite extensive, but do rely on binaries on the device, which will have an impact in terms of forensic. And we want it to be as generic as possible. So don't, at the framework level, include IOC or behavior analysis and so on. So we wanted to provide a tool to the analyst to have a way to parse all those data and kind of making sense of them. For us, the issue of jailbreaking was how much can we trust the device when it was jailbroken, knowing there is an exploit running on it, how much jailbreak may impact the forensic result you have, and how much you trust black boxes and third-party solution doing that on corporate device. In terms of forensic point of view, the question was, do we consider this approach as completely forensically sound? Probably not. As you will see, the issue of Sysdiagnose, it's run binary on the device, standard binary, so potentially if a malware managed to be at the operating system level, they may impact the result you get from Sysdiagnose. So you need to know the limitation and know that the result you get potentially might be corrupted by what is running on the device. If we compare to MVT, so we want to tackle the question first, a big difference between MVT from Amnesty and the tool we will just present is, so they have a wider support in a way because they do support Android. We only work on Apple devices. But one of the main differences is they rely on backups, user backups. And typically, user backup will contain all the user data, SMSs, photos, history of call and all those data that we don't want. We want the operating system information. But the backup does not include most of the operating system information levels. So we do have another view on it. Probably both approaches, in a way, are complementary. Depending on what you want to do, depending on the malware you have, you may go for one, the other, or both. And you will see that when we developed the framework, we were really looking at the way volatility works and kind of implement something that very, I would say, look like volatility. So you will see that it's quite modular and flexible approach. And also super easy to extend, because that's also something we consider as important, and especially knowing that Sysdiagnose changes quite rapidly. So, going to Sysdiagnose itself, that's actually the first probably part to explain what is enable Sysdiagnose. So this is actually the main page you found on macOS, explaining a bit what you have, and as you will see, there is a lot of data. So it's from you have information about the process that are running, the task, the battery usage, memory information, disk information, many logs, some user preference as well, that will be interesting as well, as you will see, crash reports, profile, and so on and so forth. It's a few hundred files at least on an iOS device. Not all of them being relevant, but quite a lot. If you want to generate one, that's a standard feature. On an iPhone, you just need to press the side button and the power button for, that's important, 250 milliseconds. If you hold a bit too long, then you will lock the device, but not a big deal. If you have to wait for about 10 minutes to have the process being completed. And then when you go to the settings, application, privacy, analytics, and improvement, in the analytics data, you will find Sysdiagnose file. So the one that is highlighted was taken in 2019. So it's typically Sysdiagnose underscore the date and so on. That file, you can easily extract via many mechanisms, being saving to iCloud, airdropping it. You can also retrieve via backups in a way, so that's a way as well. Or leave by mobile device or third-party tool. Some forensics tool allow you to just get to the file relatively easily. All of this is quite properly documented on Apple website. Not the rest, and it's where it will be interesting, I hope. So in terms of content, what you will get is the result of many commands directly run on the device, which again mean be careful, because if those processes are in a way altered, or the output, it might have an impact on the result. They copy some key preference plist file, plist being typical Apple preference file, that can be in a binary format or a text format, XML text format, network configuration and history, information on the hardware health, log files, extensive log file, super interesting, device diagnostic, usually we care less about it, and usage overview. You may also ask why building such a tool if you have everything already in an archive. The issue is that the output you get is a mix of many different types of files, being ASCII, plain text, CSV, zip file, SQLite database, Unicode file, plist in different formats. But not only that, they also play with different types of timestamp. You have typical Apple epoch that are not the standard in Unix one. You have Unix epoch, you have sometimes timestamp in plain text with different time zone, being UTC, local time, and all of that you had to deal with it. So that was the idea of unifying and providing a nice output was also a key for us. So in terms of structure, as you see, the list is quite long, but we'll have .logs with all the logs, then all the preference, some summaries that Sysdiagnose is building already, then the log archive, which is probably one of the key things you need to look at, all the info on Wi-Fi, which also include Bluetooth information, and then many other stuff that we consider as less relevant for this. So we'll just do a quick demo to give you a hint in what you can find. Those are already nicely displayed in a way, because displayed via Apple tools. Oops. So if we take, for instance, this, that's an example of a nice SQLite database. So one that typically contains many tables. That was a nice one to pass, by the way. Each of them containing some nice data as well. So it's a bit small from the other side, just to show basically the details there is not important, but there we have timestamp, we have information about, in this case, voltage, so it's a battery information in this case. and the level of the battery as the time evolves. Not necessarily super interesting from forensic point of view, even though it may depend. But just to show that this is the kind of data you have. Another example we're willing to show, it's a plist file. That one is a network one. So if I take the first on Wi-Fi, that will be interesting later, then we have many information like, is it a CarPlay network? Is it a car, basically? When it was joined by the user, geographical position, the SSID, if it's a CAFT portal, and so on. This is nicely displayed because displayed via Xcode, which is a development tool. You can have it in a text file, XML text file, or binary. So again, if you need to deal with that, it's yet another format. A third format you may have to deal with, it's this, which is the log archive. It's the full log of the system. Also nicely displayed, typically on an Apple device, but yet another format, yet different time expression and so on. So again, for us, different. If you need to correlate all of that and do forensic just with that, it's a bit painful. So that was a bit for us the challenge if we just use manual analysis. And it's where we had this idea of we want to then produce a tool that will guide the analyst and help the analyst to process this easily and be able to do his work.
Hey, my turn.
Yes.
Okay, so now I will present quickly the framework, the architecture, how we actually think of the structure of the code and the way it would work. So first thing, the framework is published. It was actually published 5 minutes ago by David on the GitHub of the DIGIT, which is part of European Commission. So you can go there and use it. So please use it. It can be extended. You can propose change. And of course, what we expect is to get some feedback about the way we do stuff and what kind of other features we could add in the future. Okay, so our philosophy when we developed this product was to keep it as simple as possible, okay, in a way that you may not need the full framework, but maybe you may want to parse only a portion of what you can get from Sysdiagnose. So that's why, for now, every analyzer and every parser can actually be run independently from the others, okay? So then you can actually transform into JSON format all the files we have for the parser. But the analyzers themselves will actually rely on the JSON produced by the parsers. So I will explain a bit more how it works. But it's important to figure out that the parser will not provide any analysis. Okay? It's just to transform the input into something that can be read by a machine, or in our case, by a script. Okay, so basically, the processing workflow, which is for this. So you get your Sysdiagnose file, as David explained how to date it. So then you will run a first script to actually initialize your file. And it will create a JSON which will list a lot of interesting information, like where are located the files that can be used further on by the parsers. Okay? And then it will update this information every time you run the analyzing. So the parser, we have a specialized parser. I will show you a list later on for each files that we found interesting for now. And then it will actually save the output in a JSON. And then this JSON will be called by the analyzers themselves. So you can use independently any parser if your goal is not to actually do a full forensics. Okay, so as of today, we have 25 parsers. Okay, so 25 different type of files which are transformed into JSON, and we have 4 analyzers. So one, which is very, very useful, is a timeliner, which actually will take all of the data which contain timestamps from the parsers and put it in a time sketch in order for the analyst to look into time-based data. We have 2 now for Wi-Fi made by Aaron to play with geolocation. So the idea is to create this KML or GPX file to have an idea about geolocation of Wi-Fi network, which has been seen by the users. And finally, we have one which is application UUID. So it will go through all of the files we parse, try to identify a unique ID for applications, and then build some kind of list which can be used to detect potentially rogue application. Okay, so yes, so basically we have 3 scripts. Maybe I can directly go with the demo. So the initialization, the parsing, and the analyzing. Yeah. Okay. The other way. Okay, the other way. Okay.
Maybe make it bigger. Can you make it?
Yeah. Can I make it bigger?
So that people can read in the background.
Is it
Okay.
good enough at the end?
Okay, so the first script is analyzing. I will not run it now, but it just mostly takes as a parameter the initial Sysdiagnose file, so the TGZ file that you get and you retrieved. I will not run it now because it may take some time to actually extract the data and create the first output. But what we can look is once you have the case, you have this second script which is parsing. So we can use it to actually list two types of stuff. So the first one is the actual cases. Yep, there we go. So there you have the list of all of the Sysdiagnose files we actually initialized with the first script. So now I have a dedicated number, a case ID, that I can call when I want to call the parsers and the analyzers. So I can list the parsers as well. So then you will see the list. So as you can see, you have a parser name and you have a description, and the input explain a bit what type of forensics data it's taking from the Sysdiagnose. So we have stuff for like system version, plist file, Wi-Fi information, spin dump, logs, BRCTL files that I will show you later on, known Wi-Fi network, power logs, mobile installation files. So we take all of those stuff and then we create a new parser. So something important to understand is that when we add a new parser, we have to modify as well the initialization of the stuff to be sure that we have a good reference between what are the files that I need to call in order to run the parser. So there, in this case, I will run the Sysdiagnose BRCTL file. So we actually went into it. I have some output explaining what script was called. And then I have a nicely saved JSON output that I can show you. Oh, AZERTY keyboard. Yeah. Okay, so as you can see here, you have something which is actually JSON format. So you can actually parse it, and in this case, that's the output of the BRCTL file, which contains a lot of list of installed application on the device, and which library it is actually calling during, when you're using your iPhone. So it can be useful, especially if you're trying to track a specific malicious application which may have been installed on an iPhone. And nope. Yes. Play from current side. There we go. Okay. So yeah, so 3 stage, and finally the analysis. You will see some output during the demonstration by Aaron, which show you which type of data for now we generate. Okay. So if you want to make your own parser, which will follow some rules by the way we did our framework, there is some required stuff into the parser. The first one is to have some kind of header giving 3 inputs. The first one is the description, of course, and then you have 2 values, which are the input and the call. So the input is actually a reference to an entry in the JSON file that we created during the initialize part of the operation. Okay. And the call is which function you will call, knowing that this function should return a valid JSON object. And basically, what is returned by this function is what we will save in the JSON file on the system, so that can be used later on by the analyzer. We do it this way because then in the script we have another part when we actually may handle slightly differently when the script it's called in an independent way without using the actual framework, but just calling the script that we created. Of course, you can just go on GitHub and look at some examples and complain about the quality of our code if you want. So for the analyzer, it's more or less the same approach, a description, a call, and the analyzer format. So analyzer format is important because depending on what we want to do, we may actually have a different type of output. So in the case of the Wi-Fi, for example, we'll have a KML file or a
GPX
file. Yeah, I'm not expert in geolocation. But the idea behind it is the same, that they can be called independently without actually using the framework. So then it can be used maybe by other projects. And yeah, so now I will give the floor to Aaron for some demonstration.
Good, thank you. Okay, so my friends here love me very much. That's why they give me the demo. And what could possibly go wrong? We have 2-3 demos prepared. One is this example that you mentioned already, that the rogue Wi-Fi access point. So here the story is like we can imagine a user is traveling, driving around close to your neighborhood, and somehow you notice by chance that your phone connects automatically to a Wi-Fi network here to the FirstCon. Does this work? Yay! FirstCon Wi-Fi. You're so smart to take a screenshot. Okay, afterwards, what do you do afterwards? You do the buttons, 250 milliseconds, not longer. It took me long to figure out the timing. And then 10 minutes later, you have in your file folder the Sysdiagnose tar gz file. You can copy it over to the laptop here and start analyzing. So you do the initialize, as you said, you do the parsing, and then we have an analyzer for the Wi-Fi networks to geolocate them and to basically just extract the information, which the parser already gave you in a nice JSON format. Just extract it. It's basically parse and filter. That's it. Yeah. Good. And then I should be able to press here, right?
Yeah.
And since the demos always work, so no.
1 minute.
Wait, I might need your help here. This is your laptop. Thank you. Since the demos always work so nicely, we have a movie. So does that work? Yes. So we zoom in on roughly where David lives. That's his home Wi-Fi network, and that was in his Sysdiagnose history, right? So here we have all extracted some parameters. There are way more parameters here that you can extract. It's really interesting to see what Apple collects here. This is actually really, for me, the big value, like to get access to that. And then we just zoom over to the next one. This is called FirstCon Wi-Fi. Why is it called FirstCon Wi-Fi, and why is it here, close to David's home? What is that actually? Anyone has any idea? Yes. So no, it's a Canadian post office in Belgium. No, actually, what? Hang on. It is in Belgium, right? So it is the NATO shape headquarters, exactly. So apparently there's a Wi-Fi network called FirstCon Wi-Fi there. What does it do there? We don't know. It's probably a rogue access point. And full disclosure, it doesn't really exist there. We did it for the demo, but we just replaced the different SSID with that one, and basically you could find it geographically. That's the nice thing about it. Okay, then we have a second demo. Mm-hmm. Is it also here somewhere? Sorry. Right, thank you. Nope, that's
the second demo.
That's the second one. Okay, good. Oh yeah. All right. Yeah. Okay, got it. The second demo is like there's an app installed by someone. You give your phone to someone, asks, can I make a phone call? You do something else in the meantime, get a coffee, come back, you trust that user. We know we shouldn't, but okay. And suddenly you discover there's a new app here installed called, can I do this here? Food truck here, yeah. So what is that? Is it like some food ordering thing or something? So you open the app, you look at it. It seems to be a food ordering app, like really simple one. And then we would like to know afterwards, we do the Sysdiagnose dump, we want to know afterwards what is actually happening there and when did what happen. So that's the time sketch example, yeah? So we can go to the time sketch. Sorry, I don't know your laptop. Thanks for the help. Right, okay. So time sketch is a tool which was originally done by Blackhat from this community. Many of you know him. And it's a really good tool for having the time series of logs, yeah. So we can just export everything from the Sysdiagnose dump here and then search for food truck. And it's basically like a Elasticsearch index on all the log files here. And it's a very capable tool actually. You can connect it with YAR rules, you can do all kinds of things with it, yeah. So once we have it in time sketch, it actually becomes very flexible. And here we have the installation of it, basically. I can add a comment here. This is probably roughly the time when this was installed, and we can see it is a self-signed developer app, org.autopsy Apple sample code. That's the sample code that you did from the Apple website, yeah? And it might contain other code. I don't know, you have to ask David. Next demo. Do I go back here? Or? Thank you. Okay, next demo is there is a process which we discovered, and we would like to read more about it. So again, you have a file that you can dump with Sysdiagnose and then analyze, and there's a PS log file where you can really see the process. And yes, you can actually detect, we don't have that here now as a demo, but you could detect the reverse shell here, which is running, and you see that in the log files, which is very nice. Again, the main thing here is not a memory dump. It is not a dump of the file system. It's just the built-in Sysdiagnose system of diagnostics that Apple provides. So we don't have to touch the phone much except for the 250 milliseconds. Okay. How much time would you still have? Enough?
4 minutes.
Yeah, okay, perfect. Yeah. Challenges. The problem is it's sort of an internal tool by Apple, right? They're allowed to change the format at any release, and they do. So it's sort of chasing the whole thing again. And the worst is like what makes it hard is that sometimes you have regular expressions, and the regular expressions then seem to match, but not 100% in the next version. So this is a bit of an effort, and I have no idea how to solve that, to be honest. I don't know if you have any ideas, but I don't.
Yes, the issue we had when we, because that's a project we started initially with David 2 years ago,
2019.
In 2019. And then at that time it was iOS 13? Yeah. Mm-hmm. So we had something, it was nice, it was working, and then several major versions of iOS were released. Right. And then, the parser were not working, or the regular expression we're using were not finding anything. So then we had to kind of go and debug a bit of what we already did to be sure that the new version will not break the way we were used to work. So there is definitely some improvement to make there. We don't have a magic solution. So a magic solution is just having time to go through it.
And just laying this out in the open. So this is a drawback of this approach compared to maybe others. Limitations. We don't, as said, we don't have the full image dump of the phone, or actually it could be the Apple Watch or something else, or the TV. So we have to live with these, whatever is in the log files. So future things for the future. We plan to extend it. Further versions of iOS, of course, obviously. You played around with your watch already, and I think with the TV, and it all works, and that's nice. Yeah. But when I also tried it with my MacBook, and again, it produces a lot of data, and it produces other data than you would see on the phone. Yeah? It's not normalized. Yeah? So the job of normalizing all these log files via the parsers into a sort of standard JSON format is not to be underestimated. The good thing is it's open source. So we can build on top of that. If you have applications, if you have applications for that, we need you for that. And if you have examples that you want of phones or devices that you want to have analyzed, you can share them TLP Red with us. We'll be very happy to validate this approach if you can detect some indication in these log files, because usually you can. And we would also like to identify gaps where we don't see it, and make this tool useful for the community, because it's non-intrusive and it's very nice. Yeah? Good. So here's some shout-outs to Sarah Edwards, Mattia, and Heather, who did the original Chigi 4 and 6 monkey code, where you contributed also. That's, I think, how you got started. Johan Berggren for TimeSketch. That's a really cool tool. And the Amnesty International report. And I don't know if you have something else to say. Nope. Here's the URL.
I think now we have time for questions.
Yeah.